Welcome to lesson 8, example number 2. And we are given, it's a 16-inch concrete wall, supports a dead load of 12 KLF, a live load of 6 KLF, and another, we're going to assume this entire thing is another 1,000, or 1 KLF, I guess, kips per linear foot. And we are told that our allowable soil bearing pressure is 3,000 pounds per square foot. So I put 3 KSF. So our allowable is 3 K. No, I won't even draw that in there. All right, so here's what we have. And this is continuous, so really I could have put in here, this will be a section, so I'll draw in little pieces of aggregate. So to show you it's a concrete section here. All right, there it is, blah, blah, blah. And the same on the other thing. So this is pretty much a continuous. It doesn't have to be continuous. It's just how we're going to look at it. It's a wall footing. And when we go in, let's go ahead and figure out what our load is. So it's asking us what is the width of the footing, given that's continuous. So our total load here, let's say TL equals 12 KLF plus 6 KLF plus 1 KLF. And that equals what? 1819 kips per lineal foot. So this right up here is 19 KLF. And it's pretty much the same thing as last time. You just want to take a cross-sectional look at what I would say is take a look at 1 foot section, if that makes the most sense to you. Is say, okay, we are looking at a 1 foot section. And there it is. So what is going to be this allowable? I guess I won't even draw it in there, it might confuse you. But we're saying that if we can have 3,000 pounds or kips per square foot, and we're doing 1 square foot, so how much can we have per that 1 square foot? And the answer is going to be 3 KLF allowable. And I'm going to do FA. And that's just you could just put FBRG for bearing. However you want to denote that. Whatever makes the most sense to you, you do, so you remember it. Alright, and then we're going to say our load, which you call it P, you call it W. Typically, I'll call these W. But it gets rather confusing. Just do whatever you need to do so you understand what you're doing. And we want to do the same thing. We can just look at that section, and you're going to use the same equation of my bearing stress equals P over A. And remember, we have 1 foot times A. A equals 1 foot times L, let's say, and this is going to be, this will be L. So we know we have 1 foot times L. So A equals L in essence. And we are going to substitute our allowable in for here. So this is now going to be our allowable, and that will give us an A min. So that means that we have what was our allowable? 3 KLF equals P, which we know, or in this case W, or let's call it P. Let's say W times 1 foot equals P. I hope that makes sense to why I'm doing that. We're making it into a point load per se as compared to an L, or a distributed load. So we have 19 KLF over L. And we can go ahead and just do 19 divided by 3 equals L. So L equals, and remember this is going to be A min, so this is min, this is L min. So your minimum length to get to is 6 foot 4 inches, 6.3. And once again, it's kind of 6'4" is exactly what it is. So that's maxing out this allowable bearing pressure. Our actual bearing pressure is going to be 3 KSF, and our allowable is 3 KSF. So, like example 1, maybe you want to say 6'6" for L, right there. But that's our answer. Eventually, it's 6'4" is the exact minimum distance required for your footing, which when I went out here, it's 6.33 foot, and obviously 0.33 foot times 12 is 4 inches. I will see you in the next video.